Hello and welcome to... Sorry, let me do that again. Editing will be required. Trying to get all the audio levels right. It's a Monday, folks. It's a Tuesday, but it's really a Monday. All right, let's try this again, shall we? Hello and welcome to the Daily Space for today, February 18th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. So today we start off with a reminder that we haven't known about some planets for all that very long. In particular, the planet Pluto was only discovered 90 years ago. And this particular little world, we haven't even seen it go all the way around the sun yet. It was found in 1930 by Clyde Tombaughs, who was working at Lowell Observatory. He was taking glass plate after glass plate of the area of the sky where he really hoped another planet might be found. Now, they were out there looking for something like Uranus or Neptune. And when Clyde Tombaughs first saw that little speck that appeared to move between one image and the next, a lot of astronomers said, that's no planet. And they said it because it just wasn't reflecting enough light to be what they thought they were looking for. But Percival Lowell, the person who had funded so many of these different observations, he had been determined that there was another world out there. And if you think about it, Percival Lowell, first two letters of Pluto, those two things might, well, be the same. And the name for Pluto was actually proposed by a little girl in England who wanted to celebrate Percival Lowell's name. And so the symbol for Pluto, unlike the symbols for all the rest of the planets, is actually the joining of two letters, P and L. Now, it wasn't until New Horizons got all the way out to Pluto just a few short years ago that we were finally able to see what little world looks like and just how amazing it is. Now, the cool thing about this little world is as the New Horizons mission approached it, they were able to zoom in and see mountains. Now, the video that we will have linked to on our website and that appears on Twitch, that video actually doesn't just show Pluto. It also shows the little snowman-shaped Arat. And I'm mispronouncing this. This is the little object that was formerly known as MU-69. Well, MU-69 became the target for New Horizons that this mission went to right after Pluto. Now, the outer solar system's pretty big, pretty empty. So when I say right after it went to Pluto, I mean it took it a few years to get there. But getting there allowed us to finally start to understand how objects in our solar system formed. Up until New Horizons got to this little snowman-shaped object, we didn't know if the primary mechanism for forming objects was one of high-velocity collisions or one of low-velocity objects coming together. Well, as the team from New Horizons studied this little world, they were able to make out a few craters, a few variations in composition. But altogether, what they were able to figure out most of all is that this little object out in the Kuiper Belt appears to be two objects, just like a snowman's ball and just like a snowman's body and a snowman's head are made of two different balls of snow that are gently stacked together. It appears that MU-69 is two what we call planetesimals that came together slowly and ended up joining into a single object. Now, computers allow us to simulate all possible ways of forming this object. And once the scientists knew the rotation rate, knew the sizes, knew the masses of MU-69, they were able to run a multitude of simulations. And what they found is any simulation that had these two objects coming together faster than 3 miles per hour, faster than 3 meters per second or 7 miles per hour, anything faster than that had them getting distorted, had them crumbling apart as they joined together. So by finding what we call a bilobate object, finding this binary pair that merged into a single snowman-shaped Kuiper belt object, by finding this, we were able to finally figure out exactly how it is that our outer solar system, and probably our inner solar system to a large degree, come together. This model that is getting put forward is what's called a cloud collapse model. It requires these objects to come together through a gentle merger, that 3 meters per second, 7 mile per hour collision. It requires the objects to actually end up smooth after this collision. And the uniform color has to do with, well, they're made of pretty much the same stuff. And their flattened shape, well, that just is from how they were rotating before they came together. All of these things, down to how momentum is conserved, how the shapes are formed, how there isn't that much cratering on this object, all work for the densities of objects that we're finding in the outer solar system. They all work for the cloud nebula model. Now, I'm not going to claim that we know how planets are formed. I am going to claim we have one more piece of information, that this is a slow process, or at least the velocities are low when objects come together. I think it's going to be a while before we finally figure out exactly how planets are formed. Now, trying to find MU-69 was what is best described as a scientific nightmare. In the lead up to New Horizons getting to Pluto, a team of astronomers here on Earth, planetary scientists, used pretty much every big telescope they could get their hands on to look in the area of the sky where we believed that a Kuiper belt with the right orbit to intersect the trajectory of the New Horizons spacecraft would be found. Unfortunately, when we were looking, that area of space was coincidence with looking towards the constellation of Sagittarius, which is coincident with looking towards the center of our galaxy. It's one of the densest star-filled areas on the sky. Trying to find objects in this region was difficult. It was made more difficult by all the cloudy observing nights. It was made more difficult by the coolant leak suffered by a telescope that shall remain nameless in this particular episode. Now, one of the reasons I know so many details about so many things that went so very wrong in trying to find Kuiper belt objects is I was part of the imaging team, not as a telescope operator, but rather our own ice investigators. Project here at CosmoQuest was part of the hunt, where we asked many of you to look through images taken here on the Earth, trying to find that object out in the outer solar system. Now, we're not responsible for finding MU-69 because it turns out that in the data that we did successfully get, we found objects. In fact, we found 2 that we were able to figure out their orbit well enough that they're published with the names of the more than 500 people that participated in finding them. MU-69, well, its discovery would require the Hubble Space Telescope. Director's time was used to search for objects fainter, more distant, perhaps even smaller than anything we could see from the Earth. Once again, this is a tiny object, basically 3 kilometers across, the size of the mountains on Pluto, the size of a small city here on Earth. It's kind of amazing that we found it, and it's more amazing yet that we were able to accurately fly our spacecraft to it. So here's to celebrating 90 days of knowing about Pluto, and here's to celebrating last week's set of science papers all about MU69. Now, there's not a lot of news other than that coming out this week, but last night there was a pretty amazing event. If you were located in just the right stripe of geography here on the planet Earth, things lined up so that you could see Mars tucking itself away behind the moon as their two positions on the sky aligned and their two sets of motions, well, carried them through a rather dramatic dance. We found the most spectacular image on the internet by Peter Leyland, who was taking images down in Mexico using a Celestron 6-inch telescope. He did basically video, taking over 1,024 millisecond images that were combined together, allowing us to see Mars just as it was about to tuck away at the smallest crescent part of the moon. We're going to have this image up on dailyspace.org so that, well, you can continue to linger over it in details later. This goes to show you can do amazing things with just a 6-inch telescope. If you want to observe, well, we're here to help. Join us over on Discord and we'll give you some advice and help get you started. But for now, that's all we've got for today. This has been The Daily Space. I am your host, Dr. Pamela Gay, and I wrote this episode, and this episode will be produced by Susie Murph. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are brought to you by you. If you would like to see more content, even interviews, consider becoming a patron of our show over on patreon.com/CosmoQuestX. We have big dreams on how we'd like to grow, but for now, we just want to keep being able to pay our staff a living wage. So thank you to all of you who have contributed. You're what keep us going. All right, so that's all I've got for today's show. I'm now going to hang out and answer your questions here on twitch.tv. Let's see what we've got. So Larry asks, have you heard if SpaceX caught a fairing or two yesterday? I have to admit, I giggled at the Falcon Stage 1 coming in for a landing and just missing the barge and splishing into the water beside the barge, but I didn't hear anything about the fairing. Someone else in the chat may know the answer to that. Let's see what else is in here. I'm going to actually just scroll up to the top and scroll down. I'm sorry about the double music. I need to figure out how to get some of the audio working better on this. Getting set up for today's show, our normal camera that I used decided it was not gonna function. I have no idea what's up with that. I'm gonna have to reboot, but I'd already gone live when I discovered this. So I'm using Dog Cam right now to talk to all of you. Let's see what all we have in here for questions. Scrolling. Hello, Brexit denier. Scrolling. Jandraloon has a very pinky Pluto emote set. So Brexit denier makes a sad face. Pluto is not a planet. Well, it's a world. Let's just embrace the word world and move forward with it. And there are bits. Okay, I'm gonna make it rain over there to try and train the dogs to go over there, but then I'll get Eddie up on camera. Actually, let me just, grab camera. Dogs. I'm missing a dog. I don't know where Stella is. That's deeply confusing. Anyways, let me put this back. Sorry. I'm now going to cut off the top of my head, apparently. I don't like that. That's kind of creepy. All right, there, no longer cutting off the top of my head. Let's see what else we have. That's no planet, Limprimble says. It's not a Death Star. Mimas is the Death Star. Am I having audio issues? Let me turn up the gain. Looking to see more questions. Looking to see more questions. There's not a lot of questions today. But Hanny's Vorverb has no bacon, which is really sad. It's really, really sad. So Brexit denier says, surely this is conjecture as we don't know the object's density or cohesion. So referring to how Mu-69's lobes stick together, we can get some information on the density from the flyby information by looking at how it changed New Horizons. I don't know if they did that, though. But in general, the way they get at it is they look at what elements appear in the reflection spectra, basically what colors of light do the surface molecules absorb when sunlight reflects off of Mu-69. Based on that, they get composition estimates, and they use the composition estimates to make density estimates. They also look at the bright material around the neck, and that gives them information. All the paper on the geology is publicly viewable up on Science. They really do have a pretty good idea of density and cohesion, and that's what goes into the model. Looking to see what else is in here. So Hanny's Vorberg says, would we expect collisions to be slow out in that region? We'd expect there to be a distribution of velocities that things collided at. So something on a highly elliptical orbit would be going exceedingly slowly and probably at a weird angle compared to something that's in a circular orbit out there. Did I do that math right? I may not have done that math right. They'll have very different velocities, circular orbit versus elliptical orbit. And that will cause, if things collide from different orbits, to have a high difference in velocity. It's the difference in velocity that matters. During the early parts of the solar system, which is when they think this was formed, everything was kind of a cloud of junk. And what we didn't know is back then, would we expect a large dispersion in velocities over the material? And it was thought that there may have been a high dispersion in velocities, and it was through these high velocity collisions that things built up bigger and bigger and bigger. This paper is indicating that back in the early universe, it was actually a friendlier, lower velocity dispersion, allowing things to come together primarily with gravity. So today, any velocity differences we see are just due to differences in orbit. And if you have two things that are on slightly different circular orbits, it's going to be a low speed. If you have something that's on an elliptical and something that's on a circular, it'll be a high speed. Most things are on fairly circular orbits. So Larry says, like the sun, the hardest thing to get in the solar system is, like the sun is the hardest thing to get to in the solar system, is Sag A star the hardest place in the galaxy to get to? So it's easy to get near Sag A star. It's hard to get into it because you have to dump so much angular velocity, or angular momentum rather. This is partly why planets don't not planets. This is partly why stars don't fall directly into it generally, which is good. That would cause radiation bursts. So I don't know if it's the hardest place in the galaxy to get into, but probably, like, if you were trying to get close to it on purpose, it would be super difficult. Scrolling. So Gildatar asks, if that object approached a large gravity well, would tidal forces be able to pull the hemispheres apart? Oh yeah. It's not that firmly held together. Scrolling. So Refsmat asks, if New Horizons had hit MU-69 at its cruising speed of 30 kilometers per second, while the world's largest telescopes were pointed at it, we might have learned a lot more than from looking at the flash. Probably not, because all we would have gotten is maybe a little bit of compositional information if we had a high resolution spectra pointed at it. And I don't think it would have been enough light for a high resolution spectrograph to work. It wouldn't have been that bright. It's just a snowball. It's just a big snowball. So yeah, you're just plowing into snow. It would have reflected a whole lot of sunlight. I suspect we got far more information by flying past it than colliding with it. I like the way you think, however. Scrolling. Okay, I'm back down to where Larry asked about the fairing. Still don't know. It would have been the 50th landing. They missed their 50th landing. Thank you, Wayne Johnson, for the bits. So Larry asks, it's the same question, just repeated. So Larry goes on to ask, i.e. the delta V to leave the galaxy is less than the delta V to get to the center. So it's a matter of how do you shed your velocity to get into a polite orbit that's circularized around the object in the center. It's easier to escape our solar system in a way than it is to maneuver into a tight orbit around the sun. And I suspect that it's easier to leave our galaxy than to get into a tight orbit around Sagittarius star. It's an issue of you have to keep changing your velocity when you get in close versus just keeping going when you're trying to escape. We read papers about how binary systems have flung a tertiary star, a third star, out of our galaxy at escape velocities. We don't read articles about a binary system flung a star into a polite circularized orbit around Sagittarius star. See. So Brexit denier says, surely it's highly unlikely that two objects have similar direction and velocity. Not really. If you have two things that form at the same distance from the sun, more or less, they're gonna have the same. So first of all, everything's going until it collides with something in the same right-hand rule dictated direction around our solar system. Everything was in a disk. And so this is sort of like if you have two olives on a pizza, and that's all you have because otherwise you're about to make a horrible mess, and you start that pizza rotating, those two olives are going to have the same direction as they go around the center of the rotating pizza. Now, the thing is, our solar system is not a solid body like that pizza. So if we put two actual olives in the outer solar system, and set them in circularized orbits that weren't the exact same distance from the sun, they would have very similar orbital velocities, but not identical. And they would end up passing each other. Now, if one of those olives was in a slightly elliptical orbit so that it just slightly crossed the path of the other olive, you could have a very low velocity collision. It's not that hard to think about in the early universe. Then things got accelerated through collisions and stuff like that. And it's mostly empty, so we don't see collisions that often. Scrolling for questions. Yes, Hanny, I'd also heard that SpaceX had flown that booster 4 times, so they still got really good use out of it. YouTube Zero Admin says, we need a world tardigrade military. I'm not sure what to do with that information. Just going to lay it out there. It's okay, Larry. You are allowed to repeat yourself. YouTube Zero Admin says, why are the disks mostly relatively flat disks? So in the low velocity environment in which they formed, they don't have enough gravity to make themselves circular. And they were actually rotating just like throwing pizza. So you have, as what starts out as one ball goes through, it hits another, and they start rotating, because unless you hit exactly center of mass to center of mass, you're going to induce rotation through collisions. So both of these objects formed through low velocity collisions into bigger and bigger objects until these two bigger objects collided and then set each other rotating. There's some really cool graphics that I couldn't get the high resolution version of out of Science Magazine because copyrights, but they're there for you to look at on the internet, and we will link to them in the show notes that we send out to all of our patron followers at patreon.com/CosmoQuest, and they'll go on the Daily Space website as well. So Brexit Denier goes on to say, we don't achieve enough velocity to go anywhere beyond the solar system in any reasonable time. This is true, but we can leave the solar system very slowly, let alone slow down when we get there. Right, so we can't slow down once we get to something like Proxima Centauri. Heck, we can't even slow down once we get to Neptune or Uranus without a great deal of problems. This is why trying to explore the outer solar system is such a problem. When we get to Mars, we don't have to be going that fast to get there in a reasonable amount of time. And so it's basically slow down using the atmosphere, fire your engines a little, and you're good. It's a lot harder out at Neptune. Now I want pizza too. Why do you always discuss food in the chat? All right. So I seem to have hit the bottom of the chat, and it's really cold down here. So I think I'm going to bid you all adieu. I'm going to go fix lunch. And I'm going to be working on software all day. If any of you would like to join me, I will see you in the Coder's Den on Discord. If you don't have access, hit me up in Volunteers Reporting for Duty and I'll give you access. So thank you all so much for being here. Once again, I'm Dr. Pamela Gay. I have been your host and the creator of this episode, which will be produced by the fabulous Susie Murph. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Wherever you are in the world, I don't think I can run the credits from where I am. Did I mention I had tech fails at the beginning of this? So Wayne Johnson, thank you for the bits. Hi, Eddie. And wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on the other side. Bye-bye.